All right, let's jump right into one of the biggest ideas in all of chemistry. It's kind of like the secret key that lets chemists build everything from new medicines to crazy new materials, all at a level we can't even see. We are talking about the mole. But here's how I want you to think about it. The mole is the secret currency of atoms. Seriously, it's how they trade, how they're measured, and how they build things in their own invisible world. And once you get a handle on this currency, trust me, the entire world of chemistry just clicks into place. So, to really get why the mole is such a huge deal, we have to go back to a basic problem chemists had. I mean, how do you count something that is, for all intents and purposes, completely and totally uncountable? And that's the real challenge, right? Atoms are so ridiculously small you can't see one, you definitely can't touch one, and you for sure can't pick one up and put it in a to-be-counted pile. So how on earth do you know how many you're working with in an experiment? Let's use a super simple example. Imagine you're at a store buying rice. The shopkeeper isn't going to sit there and count out every single grain for you. That would be insane. Instead, they use this brilliant shortcut. They just toss it on a scale and weigh it. It lets them measure out a whole bunch without counting every tiny piece. Well, chemists needed that exact same kind of shortcut. Except atoms are infinitely smaller and way more numerous than grains of rice. Counting them one by one isn't just hard, it's physically impossible. So the only way to do it was to figure out how to count them by weighing them. And the solution they came up with, well, it's an idea so common you probably use it all the time without even thinking about it. They basically created a special package for atoms, just like we do for lots of other stuff. Think about it. When you buy eggs, you don't ask for 12 eggs, right? You ask for a dozen eggs. The word dozen is just a convenient package, a shortcut that means 12. It just makes buying and selling things way, way easier. So let's put them side by side. A dozen is a counting unit, and a mole, it's a counting unit too. They do the exact same job. The only real differences are how many are in the package and what you're counting. A dozen is a nice small number for everyday things. A mole, on the other hand, is a gigantic number made specifically for counting unbelievably tiny things like atoms. And that's really the big idea right there. The mole is just chemistry's version of a dozen. It's a word that stands for a specific quantity, a package of atoms that scientists all over the world agree on. Okay, so if a dozen is the number 12, then what number does a mole represent? This, my friends, is where we get to the heart of the whole thing, chemistry's magic number. This special number actually has a name. It's called Avogadro's number. It's named after the scientist Amadeo Avogadro, who did a ton of the early work in this area. It is the official, agreed-upon number of particles you'll find in one single mole. And there it is, 6.022 times 10 to the 23rd power. Now, just to give you some perspective on how big that is, that's 602 sextillion. It's a number so huge that if you had a mole of donuts, they would cover the entire surface of the Earth in a layer 5 miles deep. It's just a mind-bogglingly enormous number. And you really can't overstate how important this number is. It is the central pillar holding up pretty much all of quantitative chemistry. One mole of anything, carbon atoms, water molecules, you name it, has this exact number of particles. Okay, so a mole is a number. We've got that down. But this is where things can sometimes get a little fuzzy. How does this giant, abstract counting number connect to the very practical act of weighing something on a scale in a lab? This is what I call the mole's other identity. It all comes back to our rice analogy. You don't count the atoms, you weigh them. The secret is just knowing how much mass you need to scoop up to get that magic number, that 6.022 times 10 to the 23rd particles. Here's another way to think about it that might help. Imagine atoms are like coins. A penny, a dime, and a quarter are all just one coin, but they each have a different weight, a different value. Well, atoms are exactly the same way. A single carbon atom just doesn't weigh the same as a single water molecule. So, take a look at these examples. If you want 1 mole of carbon atoms, you need to weigh out exactly 12 grams. But for 1 mole of water molecules, it's 18 grams. And for something like glucose, which is a much heavier molecule, it's 180 grams. The number of particles in each of those piles is exactly the same, that magic Avogadro's number. But because each coin has a different weight, the total mass is different. And this special mass for 1 mole, we call that its molar mass. So how do chemists use this in the real world? Well, now that we know the value or the molar mass of each of these atomic coins, we can start doing some real calculations. It's just like using a coin purse. Think about it like this. If you know 1 chocolate costs, say, 10 cents, and you have 50 cents in your pocket, you immediately know you can buy 5 of them. You just instinctively divide what you have by the price of 1. We do the exact same thing with moles. Let's just walk through a quick problem right on the screen. Let's say we want to know how many moles are in 36 grams of water. Okay, step 1, we find the price, which is the molar mass of 1 mole of water. And we know that's 18 grams. Simple. Step 2, we just divide the mass we actually have, 36 grams, by the price of 1 mole, which is 18 grams. And that gives us our result in step 3. 36 divided by 18 is 2. We have exactly 2 moles of water. Easy as that. See, when you break it all down, it's not some weird, super difficult concept. It's actually a really logical and incredibly powerful tool. It's the bridge that connects the world we can see, grams on a scale, with the invisible world of atoms. It lets chemists write recipes for chemical reactions with absolute precision. So, at the end of the day, the mole is the big idea that lets us count by weighing. It's the key that turns chemistry from just a bunch of observations into a precise, predictive science. And that leads to the final question. Now that you know how to weigh atoms by the mole, what chemical secrets are you going to unlock?